back to this equation. I even asked ChatGPT, and there is no way to balance this reaction. So my suggestion is to skip it. If we can't balance it, we can't do this type of workings. So I'm skipping. Let's go over here to this equation. It's balanced, thank God. We have calculate the heat of formation of benzene given the thermochemical equation. So we are going to be looking for the molar heat of formation right here of benzene. So he is benzene right here, C6H6, that would be given on a test. While you are going to use or be given everything else. So this one right here is negative 393.5. This one right here is a negative 285.8. Both are kilojoules per mole. Now, there's nothing given about oxygen here. Why? Free element, so it's 0 kilojoules per mole. And we have the delta H of combustion over here. That means like the overall is that number. So when I'm thinking of overall, that number, pulling it up here for you. When I'm thinking overall, that is the delta FH that is equal to it, okay? So let's set this up. Sorry, too far up. We have, I'm going to rewrite my equation, C6H6 liquid plus 7.5 O2 gas to produce 6 CO2 gas and 3 H2O liquid. This is what I'm going to be looking for, so I'm going to call him X. This guy is 0 kilojoules per mole. Over here, I like to, because you're going to be doing like, what is the equation again? Products minus reactants. I like to separate them so that I don't confuse which are the reactants, which are the products. I have 6 here, 6 carbon dioxide. That's 6 times a negative 393.5 kilojoules per mole. And this is 3 times negative 285.8 kilojoules per mole. And let's start. So the equation, so delta H of formation of this is the sum of our delta H's of products. This is not supposed to be an F, guys. Sorry, this is supposed to be an R. This is supposed to be an F. Minus the sum of our delta H of formations for reactants. When we look at this, X plus 0, our products are just X. So the sum of, not products, sorry, man. Our sum of our reactants is just X. It's 0 plus X, that's just X, which is kind of nice. Up here, we're going to do some math. 6 times a negative 393.5 is a negative 2361. And we're going to add that to 3 times 285.8. That is a negative 857.4. When you add these two numbers up, we're going to have a negative 3,218.4 kilojoules per mole. Up here, this is our overall. So this is our delta H of combustion up here, and it's a positive number. Or is that a typo? Yeah, that's a typo. So many typos today. I'm sorry, guys. This is a typo. It should be a negative. I was thinking like combustion's always giving off heat. My bad. So that's a negative 3267.4 kilojoules per mole. And the products is a negative 3218.4 kilojoules per mole. I'm going to do some algebra. My X is negative. I'm going to bring it on the right. This guy is negative. I'm going to bring it on the left. So I have X is equal to a negative 3218.4 kilojoules per mole plus 3267.4 kilojoules per mole. X here is going to be a positive 49.0 kilojoules per mole. And as a reminder, our X was the delta H of formation of benzene, C6H6. And benzene's a liquid. So this is my final answer. Positive 49.0 kilojoules per mole is the delta H of formation for benzene. Okay, friends, I hope that is clear or somewhat clear. You are now assigned a worksheet. You have 1, 2 questions there, 3 questions. Let me give you the numbers you're going to need for this. So this number right here is a negative 198.7. This is a negative 393.5. Don't forget you're going to have to multiply that by 6. And this is a negative 241.8. Down here, we have a negative 206. Don't forget you got to multiply that by 2, sorry. This is a negative 348.3. And right here, we have a negative 296. All of these numbers are in kilojoules per mole. Okay, I'll set up the last equation for you. We have carbon solid, that's an element, so it's 0. Iron oxide there, that's going to be a negative 824.2 kilojoules. Another element, so we're not touching that one. Then it's a negative 393.5. Don't forget you have to multiply these numbers by the coefficient that's needed to balance. Okay, so that's standard molar enthalpy as a formations class. Please get your 3 questions on worksheet number 4 done, please. Thanks.